All right, a couple of reminders and just things to point out as we get started with this week before we go into the section that last week we did section 12.1 and the practice from 12.1 is due today. These deadlines are going to be the next time we meet by 9 a.m. And so if you're watching this pass, it might be counted as late, but either way, I'd rather you submit it. So if you have not submitted 12.1 practice, please go ahead and do that. And then as a look ahead, if you haven't looked at the assignment guide for this week we're going to cover sections 12.2 and 12.3. I recognize those numbers don't probably mean anything to you. We are going to finish covering surface area of three-dimensional figures this week. And then on the second day of this week that you will have class, we are going to do some review of surface area before we go into volume. So let's go ahead and get started. Today we are going to talk about the surface area of pyramids. So with pyramids, we actually briefly did this at the end of one of our units before we had to leave school, and we talked about some specific pieces and some naming of specific lengths and measurements in a pyramid. And we're going to review those today, and those are going to be important here. So first off, the height, the altitude of a pyramid is going to be the segments from the vertex, the top point of the faces, all the way down to the very middle of the base. And so what you're going to find is that the base is going to be whatever figure is on the bottom that it sits on. In this case, this is a square pyramid, but it could be a hexagonal pyramid, it could be a triangular pyramid, whatever shape the base is. And then if you notice in this case, the sides are made up of triangles. So then the height goes from the intersection point of those faces that are triangles down to the middle of whatever your base is. And then the next type of specific height that we have is called the slant height. Hopefully you remember this before. The slant height goes from along one of the faces, along one of the triangles on the side. So think of each of those triangles, and then think about if you were to remove that off the pyramid and draw its height. In this case, we are going to call that the slant height. And the slant height, we specifically give the letter L, and the altitude we give the letter H. And then along where the point where the triangles come and they intersect together, those are called lateral edges. And so one specific lateral edge might be along here. I recognize it's kind of hard to see, or maybe we could think of it as this line right here is the lateral edge. It's where the two faces come together. And again, I wish I could be showing you this in person. It goes a lot better to point these things out, but hopefully this helps start to visualize as we go forward. So before I give you formulas, there's a couple of really special right triangles that are going to show up in pyramids that will be helpful. So one, if you look at this first triangle here, if I connect the height, and then if I go from the height point on the base straight out to the middle of an edge, and then I connect it here along the side, the hypotenuse of this triangle is the slant height. The actual height of the triangle is the other side, and then the third side is going to be half of the length of the parallel base. So we have a lot of our specific measurements are showing up here. In the second diagram, we have the height is one of our legs of this right triangle. We also have, if I were to extend this side, we have half of the diagonal of this base here. So half of the diagonal is going to be the bottom leg of this right triangle. And then the third leg is actually that lateral edge that I was just talking about earlier. So this here is a lateral edge, and it forms a right triangle. So we can start to piece this together. How I could give you certain pieces of information, we could use Pythagorean theorem to find other pieces of information. And lastly, if I were to take one of the triangles, cut it in half, that also forms a right triangle. It's half of one of the sides. It's the lateral, it's the slant height, and then it's the lateral edge as the hypotenuse. So those are three possible right triangles. So here's what we got. In terms of the lateral area, what you want to think about is if you imagine an ice cream cone that was in a pyramid shape, so it was rigid around the sides. We'll get to actual smooth cones later, but if you were to envision holding something like that, The lateral sides is going to be the portion that you would hold in your hand, the actual cone part of it. And then the base, it would be like the lid, the covering that goes across it. So for the lateral area, we just want to find the total combined area of all of those triangles. And so in this case, for the lateral area of a regular pyramid, the lateral area comes out to be, so we'll call this LA. The formula for this is it comes out to be 1/2 of your perimeter times your slant height. So it's 1/2 of the perimeter, and that's the perimeter of the base, times the slant height. And that will help us figure out the lateral area of any pyramid, regardless of what the base is. So it could be a square, it could be an octagon, anything from there. Again, you can think about, again, this is something that goes so much better if we can investigate this, but if we look at each of these triangles, remember a triangle is, the formula is 1/2 base times height. And if we did that for all the triangles we have, we would, for the different bases, we would be taking different pieces from the perimeter of our base on the bottom, and that would come together. If we added that up, that would come to make our formula be 1/2 perimeter times the slant height. So then from there, we've kind of figured out that once we know the lateral area, that's usually the hardest part. Next up, we need to add in a base. Since these bases can vary, they could be a square, they could be an octagon, hexagon, we are going to, just like we did with the prisms, we're going to represent that with a capital B to stand for the total area of the base. And in this case, before we did plus 2B, but in this case, there is only one base. So our total surface area is going to be our lateral area plus the area of our base, which we'll represent as 1/2 perimeter times slant height plus the area of the base, which is capital B. All right, so let's look at what this looks like. So example number 1, find the total surface area of a regular pyramid with a lateral edge of 10 and a base edge of 12. First thing that's really important here is if it says regular pyramid, this means all sides of the base are congruent, and then that also means that all those triangles will be congruent. So now in this case, we have our pyramid, and it tells us that the lateral edge is 10. So that means that any of these sides of the triangles that form the lateral sides, those are going to be 10. So this one is also 10, and the base edge is 12. So if we remember, for the lateral area of a pyramid, it's 1/2 perimeter times slant height. So they told us the lateral edge, which I know is confusing with L. Its slant height is L, and so we don't yet know our slant height. I'm going to go ahead and sketch that in. So the slant height goes to the middle of one of the edges from the tip along one of those triangles on the side. So this does form a right triangle, so that will help us keep in mind here. And then we also are going to need to figure out the area of the base. So you can kind of start to break this down and think about the different pieces that might be easier to solve for. One that I do think is going to be easier to solve for is, what is the area of that base? Well, if we stop and think what type of shape it is a square, so it's a square pyramid. So that means every single side of this base is 12, which means the area of a square, as we've seen before, is side squared. So that's going to make this 12 squared, or 144. So we've got the area of the base, so we can add that on whenever we're ready. So then now we need the perimeter and we need the slant height. So based on the fact that these triangles are all congruent and all the lateral edges are the same, this makes this an isosceles triangle. So we know that the altitude that's drawn in, that height there, does cut the side in half. So that makes this, half of 12 is 6. So that makes this a triangle with a side of 10, a hypotenuse of 10, a leg of 6, and then we could do Pythagorean theorem to find L here, or we could use a triple. It is a 3, 4, 5 triangle, so that would make the slant height L come out to be 8. So now when we go to put that into our formula, that makes this half of the perimeter. That gives us, we have 4 sides that are 12, so the perimeter is 48, and then times a slant height of 8, And then, so it's half of 48 times 8. And let's go ahead and see what we got there. So it gives us 48 times 8 divided by 2. And that gives us 192. So it did ask for, when it says total surface area, then we need to add in our base together. So that makes our surface area come out to be 192 plus 144. So if we go ahead and add 144 onto that, that gives us 336. So we have a total surface area of 336, and this is in square units. So this would be units squared. All right, awesome. So then next up, we have another pyramid, and it is another rectangular pyramid, so the base is a four-sided figure. Let's go ahead and look at what happens when we go a little bit out of the norm for what we're used to. So example number 2. This is a rectangular pyramid, so it's not a regular pyramid. So it says the base of the rectangular pyramid, ABCDE, is 10 by 18. The altitude is 12. The lateral edges are all congruent. Why is ABCD not a regular pyramid? Now, so then you want to think through what would make this not regular. When it comes to being a regular pyramid, we want all of the lateral edges to be congruent to each other. We want all of the triangles to have the exact same shape and size. Do we have that happening here is really the question. And when we start doing some investigating, we're going to find out that we don't. It tells us all the lateral edges are congruent, but we have isosceles triangles with congruent legs, but the bases are different, which would mean these triangles actually have a different size. So let's go ahead so it's not regular because the lateral edge triangles are not all congruent, and the base is not a regular polygon. That's a big giveaway. If the base is not a regular polygon, then your pyramid is not going to be a regular pyramid. So then if we need to find the total surface area, we can investigate, does our formula still work here? Does half perimeter times slant height still work? Is the slant height still going to be the same for all of these triangles? So what I've done here is this diagram has actually helped us out a lot in that as we look at this, they highlighted 2 important triangles in red. So if I tried to find the slant height, AG, so the triangle that is on the left, ABC, and the triangle that's on the right, AED, the triangles made of side length of 10, opposite each other, those are going to be the same size. So let's go ahead and figure out this slant height. So if I go ahead and connect this triangle here, the altitude is 12, and then I'm looking for this specific slant height that we would call L, and then GF is a segment that we don't know what it is. Now we do know that the altitude it does land in the middle of the shape, and so that would cut that side of 18, it's parallel in half, so that makes this 9. So that is 9, 12, and then we could use a triple, that is a 3, 4, 5 again, so that would make this slant height 15. So for that specific triangle, ABC, its slant height is 15. Before we go about using our formula, we want to see if the slant height would also be the same in the other triangle. So as I look, I'll go ahead and grab the highlighter. So I'm now talking about triangle AFH. So AF, FH, and AH, this one here. So it's got, again, a leg of 12. We cut the side in half, so that makes this 5. And that is another triple. It's 5, 12, but that makes this slant height, we'll call that L2, that makes it 13. So that means these triangles have different slant heights, so we have to do it by hand. So here's what this would look like. To do it by hand, Well, I have two of the same triangles, so I know that the area of triangle ABC would be half of its base times height. We just go back to what we've known before, piece it together. Half of 10 times 15. And so then, let's see here, that gives us 75. And then the other triangle, triangle ACD, that would be half of its base of 18 times the slant height that we found of 13. Half of 18 is 9, and 9 times 13 would be, I think, 117. Let's do a quick check on that. Yes, okay, so that makes this 117. Man, I must say I miss you guys here as my mental math check. Many other reasons why I miss you, but that is a big one right now. All right, let's see here. So for our lateral area, combining these triangles, I have two triangles that have area of 75, and I have two triangles that have area of 117. So then that would make my lateral area 384. Great. And then before I go for the surface area, I need to know the area of this space. Well, we go back to the area depends on what shape it is, and this is a rectangle. The area of a rectangle is length times width, which is 10 times 18, which makes it 180. And so then now, for our total surface area, we'll take our lateral area of 384 and add the base area of 180, and that gives us 564. All right, so one of the harder parts of these is using those triangles to find the slant heights, to find the lateral edge, to find heights as we go through from here. As you work through your practice sets, if you get stuck, I would encourage you to go back and refer to the textbook if you want to see more examples. There's also plenty of them on Khan Academy looking at finding these. And if you come to either the check-in, I will give you an agenda for that. We'll be going through some more problems like this, or if you come to office hours, I'll be going through more if you feel like you need more help. All right, next up is going to be section 12.3, and that is actually going to be assigned today. So please look for that video next, and then once you're done with that, that is all you have going for today.